Welcome back to Arctic Latent. Today we are diving into Flux 1 and building a powerful all-in-one workflow that you can use for multiple creative purposes inside ComfyUI. Now you might be thinking, why Flux 1? Didn't Flux 2 just come out? Well, things are a little bit messy on the Flux 2 side right now. Don't worry, I will show you how to run Flux 2 locally at the end of this video. So if you are only here for Flux 2, feel free to skip to that chapter. But after my first test, Flux 2 definitely has some rough edges. Yes, it is a huge technical leap in many ways. It follows complex prompts, it respects tiny details, it understands natural language really well, and the multi-reference editing feature is genuinely impressive. That's the part everyone is hyping. But in my opinion, it is also massively overkill for local use. We are talking about 32 billion parameters, around 64 gigabytes for the base model, and a very heavy text encoder. You realistically need 22 to 24 gigabytes of VRAM, or clever quantization just to run it properly. And even then, it is slower than Flux 1. A lot of people feel like Black Forest Labs is nudging users toward their API or cloud inference. So yes, it does run locally, but only if you have a monster GPU and a lot of patience. I will dive deeper into Flux 2 later once I have tested more of the quantized versions. For now, I have uploaded everything from Full Precision 8 to the early quantized releases to my Hugging Face repo, and of course, you can download them easily using Arctic Downloader. Alright, let's jump into our all-in-one Flux 1 workflow. Okay, first things first, let's start with some of the updates to my LinuxComfy installer. So when you run the Comfy installer, it has its own auto update mechanism. So it will fetch if there is a new version. And if you click to update, it will just download the latest update. So if we do install ComfyUI, now it is going to ask you if you want to install a native PyTorch attention or with accelerator like Sage, Flash Attention, and Triton. And also, I started building my own custom nodes that I will use in my workflows, which will help with some very easy operations, and it's called Arctic nodes. You can install this during the installation, or you can install it later on for your own custom ComfyUI installation. So for example, I will go with Sage Attention, which is number 2. I am going to choose my Arch-based setup. I will put my password. It is going to ask me where to install this. Home, Urche, test 2. It is asking me if you want to install Arctic nodes, my custom nodes. Yes. And it is asking me, this is another new feature, if I want to configure an extra model folder for ComfyUI. So this is actually a feature of ComfyUI. There is an extra models YAML file that you can set up inside ComfyUI. This is very useful if you are doing lots of multiple ComfyUI installations and want to keep your models folder, for example, in a different SSD drive, and always use that folder in all your ComfyUI installations. For now, I will say no. It is going to create the virtual environment and it's going to install everything, yes. And let's wait for this. Okay, as you can see, everything is installed and I have multiple ComfyUI installations. That's why I have this different number at the end of the aliases. So it is very easy to run ComfyUI with Sage Attention. You just need this command in a new shell, because in a new shell, your shell config is going to be updated. So you can just use this command, copy, paste. Now, look carefully here. You will see using Sage Attention and ComfyUI is just started. Okay, ComfyUI is running, but before starting our all-in-one workflow, I will open my Arctic Downloader app. We will start with Flux 1 dev and we will download this model. So I will just go and choose the FP8. I will put my folder. This is my new install and downloading all the Flux 1 dev artifacts. Okay, as you can see, all my Flux 1 dev model and all the files that's needed for the workflow is downloaded. We can just go to ComfyUI. As in my previous video, the first settings I like to use is search for node source and enable this. This is going to show us which custom node we are using, because we are going to use some custom nodes in this workflow. And let's open the manager, my ComfyUI installer, installing the manager here. So you can install custom nodes very easily. So open the custom nodes manager. The first one we want to install is ControlNet AUX. Let's install this latest. And the other one is Impact Pack. Install this. And also install Impact Pack Subpack. We want GGUF support, ComfyUI GGUF. Let's install this. Let's install a very nice quality of life nodes coming from RG3. RG3 Comfy, install this. And let's install KJ nodes, another very nice quality of life nodes. I will put these nodes name in the video, by the way. Install this. We are going to use something called Ultimate SD Upscale for an advanced upscaling, latest. We are going to use Reactor. This is something very nice for our face swap workflow. I will install this, ComfyUI Reactor. And we are going to search for something called PULID, PULID. We are going to install ComfyUI PULID Flux 2, this one. Let's install this. And we are going to install depth anything version 2. This is going to be when we are running some depth operations, and that's it. Let's restart our ComfyUI, confirm, and it is running. To apply the change, yes, confirm. As you can see, it is now downloading some upscale models because we installed an upscaler custom node that is doing this for us, which we are going to use. It is nice to have the custom node called Reactor. It's downloading some. That's why we waited. So now let's jump to our all-in-one ComfyUI Flux 1 workflow. Now we will start with the global settings, which we are going to use in the entire workflow. So what I'm going to do, I am going to search for a node called label. And as you can see, this label node is coming from this RG3 custom node pack. If you double click this, you can give it a name like this. I will call global settings. And I will increase the font to 52, okay? And then I will start with my model loaders. So load diffusion model and load diffusion model. Sorry, let's search for GGUF unit loader. And for my case, I will choose this. I don't have any units, but why I am keeping these two? Because I want this workflow for the user to be able to switch between them easily. So how we can switch? There is a very nice called lazy switch from KJ nodes. And as you can see, it has a on false and on true inputs. So if I keep this on false in load diffusion model, which is my non-GGUF model, and connect this to the model. Now, when this is false, it will be the full precision. When it is true, it is going to be my GGUF. So this is just like a switch, and I can double click this and say use GGUF. And another very nice, this is my favorites and it's a must for me, set and get nodes. So I will double click and I will say set node. It is also from KJ nodes. I will plug this into this and I will call this the constant set dev model or dev model. Let's say dev model. By the way, I forgot, with the latest ComfyUI, they introduced settings nodes 2.0. First of all, yeah, it is a complete design change. You may like it. I didn't like it. Plus, even if I like it, I wouldn't use it because it is now super new and not compatible with some of the custom nodes like you see here. So that's why it is switched off, but you can turn it on if you want to use, but it is not going to work with this workflow. So when there is something like this, a brand new feature that's like affecting everything, don't switch to that feature immediately if you are using custom nodes, because those custom nodes needs to be updated to be able to use the nodes 2.0. So what is this node doing? This is a very nice node. We are going to have lots of different sections in this workflow. Let's say I am all here and doing some face swap and I want to load my model. So what I can do, I can double click this and say get node. And in the get node constant section, you see dev model. I can select this. This is now getting this model that I set in the global settings. That's why set and get nodes are amazing, especially in workflows like very big. So I will come here. Our model set is done, and I am going to create dual clip loader, and I will choose Flux 1 dev clip L, which is already downloaded with my Arctic downloader, and FP8 scaled version. But for GGUF, we are going to use dual clip loader GGUF, and I will also use a switch, lazy switch. On false, use this. On true, use this. And use GGUF. And set node connect and call this dev clip. Now we will go to here, load variational autoencoder. We don't want a GGUF switch because this is using in both scenarios. So we will just set a node and we will connect this and we will call this clip. That's it. I will give some colors, color and maybe yellow. Here I will create right click, add a group and include this and name this also global settings, and I will put the label here. What I can do, I can just alt left click and drag to use this and say text to image. And for text to image to work, we need our model, double click, get node from KJ nodes, and this is going to be my model, and I can collapse this like this, and I can use another get node, and this time I need my clip, dev clip. So I did something wrong here. As you can see, this is going to be named variational autoencoder, so we don't get confused. Okay, I choose my dev clip. I can collapse this. Now in the text to image generation, I want to have the ability to use LoRa, adding a LoRa. So I want this text to image to be not very basic. So it is always nice to add a LoRa feature in your text to image if you want to use it. So in order to do that, the LoRa always needs to come before your prompt. I am going to add load LoRa, LoRa loader. Yes, this one. So this is a very nice way of adding LoRa. It is also coming from RG3, custom node specs. So you can just add custom LoRas by clicking add LoRa. So what I need in this case, I will put my model into this and my clip into this. And I am going to create a key sampler, our brain for the image generation. Remember from the first video. And I will put this maybe 1, 2, 3, 4, 5 as a seed number. And I will put this increment. I will keep the steps 20. Remember, we don't need a negative prompt. So that's why we keep the CFG to 1. And I will keep it is in Euler and simple and denoise at 1. So now what we need our prompt. Normally, in a Flux workflow like this, you need like a clip text encode prompt. You're positive. Then you need another Flux guidance node. So this is to guide Flux with the conditioning. So this is like the default usage of, for example, text to image. You also use this in image to image, how much influence the Flux is going to use. And generally the guidance 3.5 is a good number, but I don't want to use these like extra nodes like this. That's why I created the project Arctic nodes. So if you search for Arctic, you will find my custom nodes. Flux prompt with guidance. So this nodes has the prompt plus the guidance. So 2 features in one node. So what we need to get the clip, of course, from this. And this model needs to go to here, key sampler. And I need a negative prompt. What I'm going to use in this case, conditioning zero out, and connect this to here. This is going to zero out this condition for negative. And this one also going to be in positive like this. And another thing that I need, a latent image. Now, this is text to image and it can be tricky. You need to find Flux safe resolutions. That's why I created another node called Flux latent image, which is this one. With this node, you can create or choose custom resolutions, Flux safe resolutions. For example, in this case, I am going to use, let's say, square like this. It is Flux safe. This will go to latent image like this. And now I need a variational autoencoder. I will search for variational encoder decode. Remember from the first video. So what we need latent image, but we need the variational autoencoder itself. I can use get node and I can choose my variation autoencoder and connect to this. And I can then preview this image. Maybe I can scale this a little bit like this. And now I can create another group. And this group is called text to image. Now I am using full precision, set the model. My clip is coming from here, set dev clip, my variation autoencoder coming from this. So if I did everything right and our latent image is set to scale, we connected everything. I am not using a LoRa for now, but it is very easy to just use a LoRa by clicking add LoRa and select your LoRa file. So if I click run, unit loader, okay, this is nice to see. Why this is happening? Because this is undefined. We make this switch, but still it is undefined. Another thing that I forgot to mention, which was also giving me a problem, is don't forget to change the dual clip loader type to Flux if you are using Flux, because otherwise you are going to get some weird problems, weird errors. So anyway, right now our text to image generation section is ready. And as you can see, I can just run. I can change the resolution to something else. Let's say portrait. It works. Let's now jump to image section. Okay, let's create our image to image section. I will alt left click to change this to image to image. Let's make it the same capital. Okay. So what is nice, I can just alt click this to duplicate like this. Our power loader, I need them for this workflow too, like this. And I need my Flux prompt with guidance also. But of course, what I need in this one is a load image node. So I will double click, load image, and put this maybe here. Let's make some room. Okay. So this image needs to be in a Flux safe resolution. But maybe you are just putting an image that's not safe resolution for Flux. So that's why I created another custom node called, if you search for Arctic, Flux Smart Resize, this node. So this will get your image and it will change the scale to a Flux safe format. So this image needs to go, before doing that actually, let's go to this clip again. Let's create our key sampler. Like this. I'm trying to make it as much as clean looking. So I need positive condition here and I need a condition 0 like this to negative. Now, of course, we need to decode this image to connect it to our latent image. So encode this time into a latent form. So pixels to image, and we can just duplicate get variation autoencoder from here to here. Connect the variation autoencoder. This latent image will go to latent image. And we need now a decode, variational decode. Latent goes to samples and variation autoencoder go to our variation autoencoder. And this time I like to use a custom node called image comparer from this RG3 custom node pack. Okay, because this is a very nice node to compare two images. So before running this, I will first bypass this. Let's run this. I did a mistake. I need to change these values, but okay, no problem. That's what happens when you use wrong settings. So I will make this increment, no CFG, Euler simple, and let's run this. As you can see, it is using our image to generate this image. The comparer is not going to work because what we want to do, this image B will be directly connected to our image in here. And what I forgot to use a proper image. So what I am going to do, I am going to copy image from this one, Control V to paste this one, and now let's generate this. Okay, we have proper size, and what is nice about this node, I can compare the results like this. So for example, I can change some prompt. So it is going to be based on this image, it will get influence, but I also have a prompt that I can also use. So for example, let's remove Snow Fox. Remember, if you click play, not this run, this is going to be a partial execution, and here it is. Now let's create a group and call this image to image. Okay, and yeah, it is working. Now let's create an advanced upscaler. So for our upscale section, I want to create a global setting for the upscale model. So I will go my global settings here. I can make some room like this maybe. Double click, load upscale model. And this is the upscale model that I am going to use, real Escran. I will choose this and I will put this into a set node and I will call this upscale model. Give it a color, and now I can go to a section like this. I can duplicate my image to image. I will call this advanced upscale. I need my image, duplicate. I need my model. I need my clip. It is going to be nice to have a LoRa. Maybe you want to upscale your image, but also getting some influence from a LoRa. Why not? Model, clip, Flux prompt with guidance. Clip goes to clip, create an upscale, and it is called Ultimate SD Upscale. This one. This is a custom node that we downloaded in the beginning of the video. So this guy, of course, needs a model. It will connect to my LoRa model output. Positive to positive conditioning. We want 0 out for our negative. I will get my variation autoencoder. This will go to, of course, variation autoencoder. Again, I want to use my Flux Smart Resize to be in the safe zone. So this will go to my image, and this image will be connected to Ultimate SD Upscale image. And again, I want to use this node, the comparer. This image will be connected to this one, and the image B will be connected to my original image. Let's also bypass this. Now, this upscale by is going to upscale your image by 2. This is a setting that you want to change. So, like I said, I always like to use the same seeds. It's not a big deal. Increment steps is going to be 10. I don't want too much steps. And of course, CFG is going to be 1. This denoise is very important in here. If you make this very high, like 1, you are going to get very wild results. If you make it low, you are going to get the same image as much as possible. Let's try 0.5. You can keep everything as it is. Okay. And let's now do a partial run. Of course, the most important thing that I forgot, as always. So we set our model here, upscale model. So what I'm going to do, I am going to bring it here. Get node, upscale model, can connect it to upscale model. And now let's run this. As you can see, this was our input. And if you look at, and what was the size, it is 640. You can see this is original, this is upscale. So it is doing a bit, oh, there is something happening in here. We can do another generation. I will increase the tile width to 1024 by 1024. To get a better results, and let's rerun this. Okay, yeah, better. So this is the upscaled version. This is the previous version. Okay, advanced upscale is also done. The only reason I call this advanced upscale because this node has more features that you can play with. Right click, add a group, and name this advanced upscale. And our advanced upscale section is done. Now let's do a very simple upscale. So simple upscale is going to be super easy. So I am going to duplicate this, double click. I will call this simple upscale. And only thing I need is my image, get upscale model, of course. And I need this node. I think I showed this in my first video. Upscale image using a model. So this will go to upscale model. This will go to my image. And I will use the same node, image comparer in here. This will go to image A. This will go to image, original image. That's it. So let's bypass this section and let's run this. It is going to do 2x upscaling, and it already did. But yeah, this is a very simple upscale. What I'm going to do, add a group like this. I will call this simple upscale. And I will bypass this for our next workflow, bypass group to nodes. Now, in the next section, let's do a face detailer. Duplicate, detailer. Of course, we need an image. I duplicate it by alt clicking. We can use a LoRa for this one if we want to add something from a LoRa. It's an option, so why not? Let's get it from Power LoRa Loader from here, like this. I will get my model and dev, and I will get my model clip and variation autoencoder. You can do control left click to move them like this, trying to be as much as clean. So model goes to model, clip goes to clip. Now we need a detailer from impact pack, base detailer, this one. Variation autoencoder goes to variation autoencoder. Model is going to power LoRa loaders model output. We need our custom Arctic Latent Flux prompt with guidance node here, and clip goes to this. Condition from positive to conditioning, and for the negative I need a conditioning 0 out like this, sorry, negative. And of course we need our clip like this. We want our image connected like this. The most important part of the face detailer is bbox detector and segment anything model. So I need something called ultralistics detector provider. Oh my god, it's very difficult to pronounce. This will go to my bbox detector, and I will choose bbox face, which is the default one. Okay, and then I need a SAM loader from the impact pack, and this will go to my, this is optional, but it's good to have SAM model optional. So bbox detector is like a bounding box, detecting the bounding box of the region. And SAM, segmentation anything model, it creates automatic masks of the object. So you can isolate, cut, edit, inpaint, whatever you want. So SAM is going to segment everything inside that box. That's why we need this, and we need this one, auto selected. And I'm also going to use the image comparer node. This is my going to be my original image. So let's look at the settings. So guide size, you can keep this as it is, and this is fine. Like I said, I like to use the same settings that I use. So steps, I am going to, okay, 20, because this is a detailing pass, so 20 is good. Of course, 1 in Flux. Euler simple is fine. The noise is very important again in this one. And if you get like very different results, lower this. So the default, I think 0.5 is fine. So also is nice to have is something called image and mask preview, because this is creating a mask in the background, right? So it is always nice to have the ability to see that mask. So how we can create that? It's very easy. So there is a node called image and mask preview like this one. So what you can do, you can get the image from this and mask from this, and you can change the opacity to 0.5, and you will see why we are changing the opacity. And now if I run this, okay, it already did the job. So yeah, I am not sure if this is detecting an animal face right now. So what I am going to do, I am going to create a group for this. Let's bypass this. Let's go to our, or let's name this to detailer. Let's go to text to image. Let's create a cinematic photo of a blonde woman. So I will try in this one. So what we can do, copy image, bypass. Now we will go to our detailer section, enable, set node groups to always. Now I can select this and Control V, paste. I need to change my prompt because this is an old prompt. So I will use the same prompt from this one, and I will go here. Okay, now let's see. I need to see the mask, because that's mask preview is for that. So if I now run this workflow, I can clearly see the face detailer is working. And if you look at here, I need to run this partially. You will see that face isolation is working. So that's why I like to use this like 0.5. And if you run this, this is good for troubleshooting. So you can see where is our face detailer is happening. And that's it. Face detailer is done and it is working amazing. Let's do inpainting. I need my load image node. Let's get the label and name this to inpainting. So of course, with the inpainting, we need my resize, Flux safe resize. So it is going to be Arctic Latent Flux Smart Resize. I know my Flux image in this case is completely safe because I just generated. This node is for if you like find something from internet without looking at the resolution of it and just bring it directly in ComfyUI. So it is nice to have. In this case, actually, it is not doing anything. So in order Inpainting to work, you need to create a mask. So Inpainting is you are painting a section of your image with a mask editor, which we have in ComfyUI, and we are changing anything inside that mask section. That's called Inpainting. So what I need to use something called grow mask. If you guys use like Photoshop before, it is like the same image adjustment, like expanding a mask. So this is actually doing the same thing. So I will use my mask, and for now I will put this as 10 for growing the mask by 10 pixels. Then, of course, when you expand the mask, you would like to have some nice blur to it. So the node called Gaussian Blur Mask, we will connect this to this. And for this one, I will just use the default values. And we need something called in-paint model conditioning. Okay, so this is going to be our conditioning node to create our prompt in this masked area. As you can see, it has a mask input. So this input mask to mask will be connected, and we are going to bring our get node clip in this case. So it will be get clip, and this clip is going to be connected to our Arctic Latent node called Flux prompt with guidance. So let's connect our clip, trying to be organized like this. So I need my positive connected. I need a conditioning 0 for my negative. This will go to my negative. I need my get nodes variation autoencoder. Should I put it here? I can maybe collapse this and put it like here, but okay, it is nice to have this. And your pixels is going to be your image, this guy. We need a key sampler, the brain of the AI generation. Key sampler, positive to positive, negative to negative, and latent to latent. Now, very important model. Now we are going to open Arctic downloader, choose Flux Fill. Flux Fill is the model that's doing the inpainting. So I will choose Flux Fill and choose for my RAM tier, VRAM tier. But it is going to be, for me, it's going to be the full precision 8. My folder is already set up. Flux 1, downloads. Okay, so I downloaded the full precision 8 and GGUF versions of inpainting model. So now I need to put that into my global settings. So I will go here. Let's make some room. Load diffusion model, GGUF, because we have the GGUF version of the inpainting model. So I am going to use lazy switch, and this is going to be, let's save the workflow. I will just refresh because I just downloaded the models. Okay, now I will get Flux 1 fill, and for this one, Flux 1 fill, GGUF versions. False is this, and for true, it's going to be the GGUF, and I'm going to set node, and I will call this Ops in paint. Connect this. I will make the colors later on. Now I can go here. Now key sampler is waiting for our node, inpainting node, get nodes, inpaint model, and connect this to model. Okay. We need a variational decoder for this one. We need to connect this also to my variational autoencoder like this. And now I need another special node that we use in inpainting. It is called image composite masked. So this is going to take the destination as my source image, let's say, not to be confusing. And the source is going to be my new generated section. And the mask is also going to be my mask, this one. So what we are doing with this node is we are using our original image, and on top we are bringing our new section that we just generated, just like this. And of course, I want to use image comparer from RG3. So this guy is going to be my image A, and my image B is going to be my original image, which is this. I can expand this like this. So we loaded our image. We are going to draw a mask. We will grow the mask. We will blur the mask. And we are going to use our inpainting model conditioning to get the prompt. And in the inpainting model condition, of course, we are using our original image and we are using the mask. and we are using the positive prompt. So the positive prompt is going to be masked into that image. Then we are getting our InPaint model, connecting everything into a key sampler, decoding the image. Then for final result, we are getting the image, destination image, which is the original image, and the source. Now, the source is our newly generated image in that mask area. I will show you how to do the mask editor. Just right click this image, open in mask editor, okay? But it is just like a Photoshop brush, thickness, opacity, hardness, smoothing, precision, mask opacity. It has lots of options that we are not going to use everything. So as you can see, this is now your brush and this is your mask. So you mask like this, Ctrl Z to undo. So you can do this, or you can paint something and delete it, for example, undo. You have brush shapes in here. I like to use opacity so I can see actually what I am. So I will, now I don't see anything. Yeah, I did a mistake. So this opacity, actually you don't need to change. This should be like 100% because this is not the function I was looking for. It is the mask opacity that I am interested in. So you always want to paint, like this, but you can change your max opacity. So in this case, I am going to paint a very basic hair mask like this. And then I will click save. Here is your mask. And I will call this red hair. So in painting, we always need to use at least 30 for our guidance value. This is the default value for in-painting and out-painting Flux guidance value. So let me go to my mask editor. I had to refresh my ComfyUI. That's why I lost my mask. So I am just going to create a mask again. Do something like very basic. You can always then adjust this later on. Save. You see your mask. Okay. What I also like to do, because we are doing expand and blurring, it is good to have a mask preview connected like this. And maybe I can put this here. Don't forget to change this. Like I said, I like to use the same nodes. Where is it? But of course, this is important. In Flux, CFG is 1. 20 steps is fine. And now what I'm going to do, I am going to run this. Let's bypass this detailer section, bypass group nodes, and let's run this. Okay, so you see, I had a mistake in my mask editor. So I will go to my mask editor. Okay, and where is it? So this is fine. I want to make mask blending options to white. Now I will save this. This is now my mask. So I was just painting black on black. Then here is our generation. As you can see, okay, we got red hair, but of course it's changing the result a lot. So that's why you need to adjust this mask. So try to include everything. If you want to change hair, try to include all the hair. And of course, do something better than this. I will not spend time on this because it will take some time. But yeah, you will get there if you really want to make the same hair. Yeah, you need so much more better mask and you need to play with the guidance. So we change the color to this. And for example, what I can do, I can go to my mask editor, clear. I can paint a mask like this and save this. Sunglass. Yeah, so let's make this 10 in mask editor, save, and it did a very nice job, for example, as you can see. So mask is very important, of course, in this case. Okay, I am going to create a group like this, name it Inpainting, and we are done. Now let's jump to Outpainting. So I need a load image. I need my Flux Smart Resize. So I need my Flux prompt with guidance custom node, dev clip. I need my get inpaint model. Inpaint and outpaint, they are both using Flux fill models. So I need my key sampler, inpaint model conditioning like this. And let's start connecting stuff. So clip to my clip, conditioning to positive. Let's have a 0 conditioner to negative like this. Let's get the variational autoencoder, get variational autoencoder like this. The only node that actually new that we need in this case is something called expansion size, because outpainting is where you want to expand the image. The node we need is image pad for outpaint, this one. Okay, So what we are going to do, of course, we are going to connect image to image. And for example, this is the expansion size. I want to expand like 400 from left, from top, from all the sides, right? Oops. And I want to give some feathering. Okay. So this is now going to be my pixels for the in-paint model conditioner. And the mask is connected to this, positive to positive, negative to negative, model to model, and of course latent to latent. We need a decode for variational autoencoder, variational autoencoder decodes. This needs our variational autoencoder and our latent image. And I want to preview this image in this case like this. And don't forget, guidance is 30. Because I copied the previous image, I will open my mask editor and just clear the mask because we don't need a mask in this case. I forgot this, so it is also always nice to have this for an image that we are bringing from outside. Clear and save. Okay, and now, actually, why don't we do comparer? And B is going to be our original image. And here it is. We went from this to this. And as you can see, it did a very nice job with expanding the image. That's it. Outpainting is that easy. I can create a group, Outpainting, and let's grab our label from this one. Let's bypass this and let's name this Outpainting. Done. Let's do a save. You also need to download Flux 1 depth according to your VRAM. So you can use Arctic Downloader again. So let's go to our global section like this. And maybe we can expand this like this. And now load diffusion model. I will save and I will refresh because I just downloaded them. And I need a GGUF. I need a lazy switch. So on false, on true. And let's set a node called depth model, and this is going to be my Flux 1 depth, and this is going to be my Flux 1 depth GGUF. And we are done with the global setting. So this is something that you want to generate an image, but keeping the structure of the depth of the source image you are feeding. So when I show you, you will get the idea much better. So let's duplicate this. Let's call this depth. We need an image. Let's duplicate this. Now remember, we downloaded some custom nodes in the beginning of the video. The one that we want to use in this case is download load depth anything model. So this is a node that will automatically download the depth model. Now don't get confused. This is a model that will extract the depth information from that image. Flux depth model is something else. It is a special trained Flux model that can understand and work with these depth images and keep that depth structure. So both of them are different things. So the one that I want to use here is the FP16 one. FP16 one is going to reduce the quality. So try according to your GPU. Okay, so I will put it here. And of course, I need another special node called depth anything version 2, this one. So this will get the model, my image. I will change this image. This image is not like a good example for this one. And now I need a new node called instruct pixel to pixel conditioning. So this is a special conditioning for operations like this. So we will get the image from this one. I also want to see my depth image for troubleshoot purposes. So I can just put a preview image and connect it to this one like this. I need a get clip, which means get node to get the clip. Okay. And our clip will go to our custom node called Arctic Flux prompt with guidance. This will go here. And I need a 0 out for my negative and my positive from this. And negative to this. I need my get node variation autoencoder like this. And we need a brain, which is key sampler. We need model, the Flux one. So I will put a get node depth model to model, positive to positive, negative to negative, latent to latent. And I need a variational decode. And it will get my also variational encoder, and this will get my latent image. And for this one, I don't need, I think, a comparer. I can just preview this. Now what's going to happen, by the way, when we run this workflow, it will first download this automatically and save it to the proper place on its own. Let's create a group like this maybe and call this depth. Bypass group nodes. Let's go to our text to image, enable. Okay, I am going to create something like this. For example, a cinematic street scene at golden hour, shallow depth of field, detailed subject in the foreground in sharp focus. So I just need something, some image that has some nice depth. Okay, let's try this. I will copy the image, bypass this, enable this section, Ctrl V to paste. Now look what's going to happen. I will only do a partial run. Okay, so you see it is downloading that model first. It downloaded. Now it is creating the depth map. Okay, so here is our depth map. Whatever is close to camera is going to be more bright. Whatever is far away from camera is going to be more dark. So I can use this image, which we are using here, and I can recreate this scene with a different prompt, but keeping the structure. Paste here, and now run this. The default suggested guidance, Flux guidance value is 10 for depth. And let's do 20 steps again. 1, Euler simple, and 1, 2, 3, 4, 5. Increment, and let's run this. So now we should get something super similar to that image because of the depth structure that we are using to generate this new image. As you can see, a great example, a totally different image, but like everything is changed, but the depth is almost same. So now Canny Edges a workflow. So let's see that. You just need to download the Canny model. You can use Arctic downloader for this. Here I downloaded them. Global settings section. I will duplicate diffusion model, unit model, lazy switch, and set depth model. I will call this Canny model. I will refresh because I just downloaded. Now I can choose my Canny. This will go to false and this will go to true. They are very similar with depth. So I need a load image, a dev clip, Flux prompt with guidance, variation load encoder, condition 0, same node because we are working with pixel, instruct pixel to pixel condition, get depth model, which I will use in this case Canny model. Key sampler, variational decode, and preview image. Now the node that we need is Canny. This guy. I will duplicate this image to image and image to Canny. Our clip goes to clip. This is the negative one. This is positive. This is our variation autoencoder. And of course, this is going to be our image, Canny image in this case. Our Canny model to model of key sampler, positive to positive, negative to negative, latent image to latent. We will decode this with a variation autoencoder, and this will go to image. So I will just use the default values. This is going to be changing the result of the edge detection, but also like we did in the depth one, I like to use a preview node just to see my edges. So I like to use this in architectural generations. Let's create a group, Canny bypass. Let's go to our image, text to image generation, enable it, and I paste this prompt. A stunning modern architectural residence on a hillside, stuff like that. So it is going to give me something like an architectural scene. Let's generate this. Okay, very nice example actually. So I can just copy this image, set group nodes to always, paste my image here. Now let's first do a partial generation, and as you can see, it gave me something like this. So it is detecting the edges. What about 1? Yeah, let's make this and make this 30 maybe. Okay, let's say I am happy with this. I will just create some space here to tidy things up, and let's generate. But let's create a comparer node rather than this comparer. This is A, this is B. Oh, one thing again I forgot, which is very important. The default suggested Flux guidance value is 30 for Canny models. Let's run this. As you can see, it is doing a very nice job. So we are maintaining this structure, but the image is changing. So for example, let's try something crazy. I will go to ChatGPT, make this prompt, but cyberpunk style. So here is our new prompt. So let's see what we are going to get now. If we are going to get the structure, same as you can see. So it's very powerful when you are using with something like this, like you have some very nice architectural design or something like that, or anything that you want to really keep the structure of the edge. It can be even a clothing, it can be a body portion or something like that. So it is very powerful. Okay, that's it. Now, in our next workflow, we are going to look at PULID, which is going to be very fun. So PULID is for keeping the character consistency in your image generations without doing heavy training like LoRA training. It is using a custom library called Inside Face. That's why it is a little bit tricky, because you need to compile Inside Face for your ComfyUI with the proper PyTorch stuff like that you are using. So what is nice is my ComfyUI installer has already given you the option to download and install for your already running ComfyUI. So before doing that, let's first create the workflow. So what I'm going to do, duplicate this, and I will call this PULID. Of course, we need an image, we need a clip, Flux prompt with guidance, of course, condition 0, key sampler, decode, and one thing very important, of course, apply PULID Flux. This is coming from the custom node that we installed in the beginning of the video, which is called ComfyUI PULID Flux 2. Okay, so this is going to be connected to our key sampler model, and this will go to negative, positive, and we want our custom node Flux Smart Resize. Again, anything if we want to bring from outside. So this will make sure we are in Flux safe resolutions. This will go to image. Now in this workflow, it is nice to have a LoRa loader. Power LoRa loader. So Power LoRa loader is going to get our clip, and it is going to get our Flux model, get node, in this case Flux dev, and this model will go to apply PULID model. Of course, the clip from Power LoRa loader will go to our clip. For this one, we are creating something brand new. That's why we need a Flux empty latent image. We can use the one from my custom node called Flux latent image. I will set my resolution to portrait. This will go to our key sampler latent image, of course. Now, this is important. We need something called, if we do this, PULID, search for PULID, load PULID Flux model. So I will not put this into the global section because this is only be going to use in here. It can stay here. We already downloaded this, as you can see, with the Arctic downloader. When you download Flux dev model from Arctic downloader, this is going to be downloaded automatically. So it is this one. And I need one more thing called Eva clip. Load Eva clip in order this to work, to Eva clip. And the most important one, it is called Inside Face. Load Inside Face, PULID Flux, and keep this with CUDA because you want to use your NVIDIA GPU. So this is going to load the inside face library, this one, to make the heavy work. And face analysis will go to here. I can keep this as it is. I will put this here, maybe. I can create a group node called PULID, like this. Of course, we need a decoder, and this will get our, do I have, yes, let's duplicate from here, our variational autoencoder, and let's preview this image. For this one, I want to use a face. So I can copy this image, paste here, save here, everything is connected, key sampler is same, this is set to portrait. Now I am going to try to run this just to show you guys what will happen if you don't have Inside Face compiled for your ComfyUI. You see, it is in that node right now trying to do something. We are going to get something like this. If you go to your ComfyUI terminal, you will see lots of error like this. So unexpected something, blah, blah. So yeah, it will just not work. So what we are going to do, LinuxComfyUI Installer, and what we are going to do is we will rerun our install ComfyUI script. So there is a section called Install Precompiled Wheels. Option 3, select it. Is ComfyUI already installed on this system? Yes. Now give the folder of the ComfyUI. In my case, this is my test ComfyUI install, which is Comfy. I will add more precompiled wheels here in the future, of course, but in this case, we only have Inside Face. So option 1. So it is installed. So save, go to manager. And always, of course, restart your ComfyUI when you add something like this into your ComfyUI install. Let's look at here. Refresh. I need to change my prompt. Let's use ChatGPT to create me a prompt. Let's paste this. I will use a little bit lower guidance. Just one thing that's important. Install the Inside Face with the ComfyUI Installer script after you installed the custom node with the manager. So the custom node for the PULID one, you should already have it installed in your ComfyUI. Then after you install, just come here and run. Here it is. It is super powerful. No LoRAs. This is a very good option to use for character consistency. So for example, as you can see, it's great. And let's change this. A woman sitting on a bench at a park. Here it is. It is super powerful. Now let's do a very basic face swap. We need, of course, two images. This is super basic, by the way. We need a node called Reactor, a fast face swap. This is a custom node we downloaded in the beginning of the video. So let's enable these nodes. Oops. So this is our first image, second image. So this is the body and this is the face. And comparer maybe is a good example in this case. Yeah, we can look at the body to compare. For this to work, this face restaurant model section is important. You want to use code former or this 1.41 and everything can be exactly same. So what I'm going to do, I am going to create a group, swap faces, bypass. Let's grab the body from this since we have a body. This is our body and let's go to text to image, enable a beautiful human face, copy image, bypass, enable this one, put this on the face and run. Not bad. Again, this is a very fast face swap, but you can see it is actually doing something nice. So let's bypass this. So now I will show Flux context model, but before doing that, I want to quickly show Flux Krea. So Flux 1 Krea is a better model. It's released after Flux 1 Dev, and it has lots of improvements when you compare with the Flux 1 Dev. It has a better realistic approach, and if you look at here, so it is mostly focusing on aesthetic photography. So you can read all the details here. So what is nice, we can completely use the entire workflow that we created. We are just going to change our base model from Flux 1 Dev to Flux 1 Krea. So if you open my Arctic downloader, again, you can download Flux 1 Krea from here according to your GPU and Flux 1 Kontext according to your GPU. So let's first go to our workflow. First, I will create a basic text to image. Let me see. So for example, let's create a character to get the best of it. Let's ask ChatGPT, paste our prompt, and let's generate this. Okay, as you guys can clearly see, Flux 1 Dev has this soft looking images. And it also has this like line in the chins. This guy has some facial hair, that's why it's not very visible. But if you like create a woman, you will see like they all have this like chin line. So that's also something that they improved in Krea. And as you can see, this is not like looking like a very realistic image. It is like a very soft skin. Just to show side by side, if I copy this image and paste here, okay, the only thing, like I said, I need to do, I will go to my global settings, my base model. I am going to use the one which is full precision 8 for my GPU. So I will just go here and I will choose Flux 1 Krea Dev. That's it. The clip loaders, variation autoencoders are all same. So this is Flux 1 Krea. Okay, let's go here and let's generate this again and let's make this fixed. This is almost like a real photo. Like this is night and day. It is like almost like a real photo. So definitely use Flux 1 Krea. Kontext is another trained model from Flux family. It is mostly for image editing, enabling instant editing without fine-tuning or complex workflows. It is good for local editing. You have an image and you want to just put something in a local area. Flux Kontext is good for that. Character consistency, you want to preserve unique elements of an image, such as a reference character or object in a picture across multiple scenes and environments. It's very good. Style reference, generate novel scenes while preserving unique styles from a reference image directed by text prompt. So it is a very good model, I can just copy my load diffusion model, my unit. Clip is same for this one also. What is nice about when you are using a family, at least for example for Flux 1 Dev, Flux 1 Krea, Flux 1 Kontext, they are all using like same files, text encoders, variation autoencoders, stuff like that. So what I'm going to do, and I will call this context model, and I will choose context again. Like I said, you can download from Arctic downloader. I want a little bit more complex scene so we can do some adjustments. Okay, let's enable this text to image, and we are using Krea for this kind of operations from now on. I will paste my prompt, maybe a landscape, but maybe a little bit smaller one. Okay, let's run this. Okay, I will just use this. You see how it is like so realistic. It is just like taking with a camera. And let's copy image, bypass. So let's load our image. My smart resize to be on the safe side. I did an update on this tool. It can be looking different if you remember from the previous sections. This is now going to work better. It's a quick update. So I will use image, of course, and this is a normal image. We need to encode this into latent form. We need our variation autoencoder and key sampler. Let's make it like this. Get nodes, context model, and of course we need our prompt with guidance from Arctic nodes. Let's get the clip condition to positive. Now in this one, we need to do something else. There is a node called reference latent. We need to use that because, like I said, this is a model that's trained for using references, and it is called reference latent. So your reference latent is going to get your conditioning and your latent like this, and the conditioning will go to positive and negative. And also this latent, of course, is going to get, oops, your latent again. Trying to be more organized always. And of course, we need a decoder. This decoder needs a variation autoencoder, which is this. And I want to use comparer. I can compare image B as the source. Now, prompt is always very important, but in this case, it is much more important. For example, so you can give a prompt like make the car yellow. I forgot to change my settings for the key sampler. I always forget. It should work, but yeah, I should change the CFG to 1 since we are working on Flux. Here it is. And let me change this to 1. Make the car yellow and make the guy with long hair. So do you see how it handles the character consistency? Change the person to an anime character. Let's see. Yeah, as you can see, what we can do. Transform image into pencil drawing. As you can see, it is doing a very good job. Change the person to a Lego minifigure. That's very good. Let's do a tricky one. Make the person hold a sign that says hello. As you can see, it is doing a very good job. And of course, I am giving like a very basic prompt. So for example, you can describe how this sign is looking like. Because I don't give any details, it's like a very plain white sign, but like all the body posture, everything is looking amazing. So this is it. Global settings to here, and call this context basic, the group context basic. Let's save. Now let's do a little bit more advanced context workflow. We are going to chain images. Let's duplicate this, enable, and let's call this image chain. I need 2 images, so I will copy this load image and this one. And we need Flux Kontext, Flux Smart Resize from me. But also with Flux Kontext, they also edit this node. Flux Kontext image scale. So actually it is doing almost the same thing. So you can use both of them. Mine is doing an upscale method, for example, with different upscale options. In this case, I am using Lancos because it is better than a bicubic, for example. But yeah, these you can use both. So let's connect this. I need an encoder. This is an RGB image. I need to encode this into the latent space. I need my variation autoencoder, of course, like this. Same like this. And now we need reference latent, and this is going to be my first image. Let's use Flux prompt with guidance from Arctic nodes, and let's get a clip like this, and this will also be connected to my conditioning. I can create a zero condition for my negative. And now the tricky part, how do you chain two images together? Very easy. You just need to create another reference latent and connect them together like this, and now they are chained together. We need a key sampler, 1 2 3 4 5 increments, and conditioning 0 to negative, and of course our conditioning to positive. We will get our context model, and we need an empty latent image. Let's use the Arctic nodes Flux latent image. I want this size. This will go here. I need to decode this. For my decoder, I can connect this to my variation autoencoder, and I can preview this image. Let's create a group, context image chain like this. Paste into our first image, another prompt. Give me a product shot of a sleek headphones. Copy image, paste image, and now I can bypass this one, go to my context image chain, set group nodes to always, and let's use a place the sleek wireless headphones onto the head of female model in a professional studio setting. The headphones should fit naturally with accurate scale and perspective, match the lighting and shadows to the scene with the subtle reflections on the ear cup to the ends to enhance realism. And here it is. It added some text to it, but I can just fix it with prompt. Yeah, it is better. You can keep going with improving your prompt always, but what is nice, we have a very good character consistency plus product consistency. Okay, this is a video from future. When I was doing the editing of the video, I just realized I didn't put the context in painting. So I am just going to show it very quickly. Context in painting is so much better, of course, if you compare it with the Flux painting, because in this one you can do like a real local edits like I did here. So this is exactly using the same setup that we use in the Flux in painting. I only introduce, of course, the reference latent. So we are bringing our model and clip, and we are introducing a LoRa if we want to use, and we are adding our prompt and condition 0, reference latent just we use in the context, and in painting condition just we use like in painting. It goes to key sampler. So we are creating a mask with mask editor, just like we did in the Flux in painting. We are growing the mask, blurring the mask, and I can preview that mask. This is an RGB image now. I am encoding it using my variation autoencoder, of course. Now, this image, because now this is a context in painting workflow, needs to go to a reference latent. That's why the only new thing that I added to normal Flux in painting is this guy. So now this will go to my latent. My prompt is going to reference latent also, conditioning, zeroing the negative. Then they are getting together in paint model condition, positive to positive, negative to negative, variation autoencoder. Our image, original image, is this one. And as you can see, we are using the mask we just created in paint model conditioning. Now what is this doing? It's going to create whatever we ask in this prompt in this masked area, and then it goes to key samplers positive, negative, latent image to generate that new part. In this case, I am trying to create a sunglasses. So it goes to decode, because we need to decode this. Just like we did, we need the same image composite mask, and this destination is our original image, like you see, the flow, and the source is our newly created piece, which in this case, the sunglass. And again, I need to use the same mask, just like here. And of course, this decode needs to go to source, and I did something wrong here. Of course, this needs to go to the image like this. So if we generate this, we will exactly get what we need. That's it. Thank you. Now Flux 2 is going to be super simple because there are no inpainting, outpainting, Canny Edges models for Flux 2 yet, so it is just the image generation model, but we will add it to here. So let's open up some space, load diffusion model and unit loader. Let's copy this, and we will call this Flux 2 model, and we can download Flux 2 from Arctic downloader. And we are waiting for the download. Let's create the workflow. Flux 2. I will start with the reference stuff because text to image and image to image is the same with Flux 1 dev. But yeah, let's start building this. You can still use my Flux prompt with guidance. Let's set a get node. In the meantime, let's go to here. Flux 2 needs only one text encoder. So what we are going to do, clip, set node, what Flux 2 clip. This is going to be a Flux 2. Device can be default and we are going to choose when it's ready. But let's do it like this. For example, they introduce new nodes for Flux 2, like this Flux 2 scheduler, but I really don't understand why they are doing something like this. Like, I hate extra nodes. So this is just setting the scheduler to 20 and just giving some width and height in one node. But in the key sampler, I mean, we already have it. So you can experiment with these nodes if you want, but I will just use the default ones. They also have this new node called Sampler Custom Advanced. Again, I will not use it. So this is going to be my Flux 2 dev, and this is going to be my Flux, yeah, this one, Mistral, free something. Very important, type Flux 2, and we need a variation autoencoder, and this is going to be a Flux 2 dev 1, and I will call this Flux 2 variation autoencoder. Now we can go back to our workflow, Flux 2, and we need our clip, which is Flux 2 clip. We need our Flux 2 model for our key sampler. And now we will use load image, and from this load image we are going to use my custom node Flux smart size Lancos. This is a RGB image. We need to encode it into latent space. And now we need our variation autoencoder from Flux 2. Where is it? Here. Maybe I can put it like this. Now our new node that we already know from Kontext is very important here. So this will go to our conditioning like this, and latent image will go here, and we need Flux latent image, and let's set this to landscape latent conditioning like this, and I can do a conditioning 0 out for my negative decode. It needs a variation autoencoder, of course, and preview. Default settings are nice. Okay, now I am going to do something funny. This is my brother and me, I think from 19s, a nostalgic 1990s bedroom scene with two kids sitting on the floor playing an Atari console. Recreate the appearance of the two children using the provided reference images, keeping their faces, hair, body proportions, blah blah. Yeah, let's see. And now you can also see why in the beginning of the video I said Flux 2 is much slower. In Flux 1 dev or Krea, I already had the image. Yeah, this is definitely slower. We will use stuff like Sage Attention, stuff like that later on in another video for making this Flux 2 workflow much more optimized. This is crazy. Like, what is happening? I hope I can get something good after waiting like this. Yeah, I don't like this. It's so slow. It is 55%. What is going on in here? Oh, my GPU is 80 degrees. Look at the RAM. Look at the RAM. Please create something good. Okay, yeah, actually not bad. The image itself is very nice, but I am looking for character consistency, and actually it did a very good job from this image. This one is me, this one is my brother. My brother is looking very like him, I can understand. And yeah, this is looking my childhood. Yeah, and what is nice, it's these nice posters, 19s posters. Same kind of clothing, Atari. There is one thing, the reason that why we waited a lot, it is because of the image size, and why I don't get this image size, I don't know. Let's see. This is empty latent image. I will set this to square and see. Of course, this was the first time I am using Flux 2, like in this scene. So now it is loaded into my VRAM. It should be much more faster, but still I am not sure. No, this is so slow. I will cancel this. This node I created for Flux 1 dev, so maybe I need to update this for Flux 2 because I shouldn't get this. So what I'm going to do, I will show you guys yeah, definitely that's the problem because they introduced empty Flux 2 latent. This is a new node. So I will put this to here like this, and I will also not use my node. This is also for, I developed for Flux 1. Maybe I also need to change this to a Flux 2 workflow. So what I'm going to do, I am going to use the image scale to total pixels, non-cos to pixels. So what is this actually doing? It is like changing the size of this into a 1 megapixel format to be on the safe side. So yes, this should be much faster. And it is, yeah, I can clearly see that. So yeah, this is good to know. I need to update my nodes for Flux 2. Yeah, this is now completely not following, us. Some kind of hairstyle, maybe we can say. Yeah, the image size at least is correct. So what I'm going to try, I will increase my conditioning and I will go from, so I will try to run one more. Yeah, it is looking very like me. And my brother a little bit more needs refinement. I only want to be sure about something. This is working for sure. But in their official workflow, they are doing something like this. So that's why if there was a problem, we would never get an image. This is working, but I will just try their way. So they have this new node called Sampler Custom Advanced. So this is going to get a random noise like this. I will delete this key sampler. I will put this here and let's put this here. They have this basic guider that they are using like this. So it's accept the model, in this case Flux 2, and the conditioner, in this case this. We don't even need this, and guider will go to here. And this guy is going to be key sampler select, and it's going to be Euler, the default one. We can maybe do something like this. The latent image will go here. Variation autoencoder still using. Samples will go to output. And they have something that's the only node that I am curious about. Flux 2 scheduler, which is connecting to this Sigma. So that's why I want to also try with this one. Everything is fine. So I am just showing you all the options, but my workflow definitely working. But I just want to be also try with this one. I just don't like using extra nodes, as you can see. So it says advanced, but what is the advanced features of this node? Yeah, it is just same. But yeah, this is Flux 2. So I will keep in the workflow the official way for now, and I will add a group Flux 2. We are done. Okay, since we are now at a stage where we all tried Flux 2 and felt just how heavy it can be, I think this is a perfect time to take a quick look at some attention logic and understand what is really happening under the hood. Because a lot of the performance tuning, full precision 8 models, full precision 16 accumulation, sage attention, it all makes more sense once you know how the GPU is actually doing the math. Even if you are using an FP8 model or a quantized GGF model, the weights are always dequantized into FP16 the moment the model starts running. But inside every attention or linear layer, the GPU still has to accumulate partial sums while doing matrix multiplications. By default, PyTorch usually does FP16 multiply or FP32 accumulation, which is slower and heavier. But if you enable FP16 accumulation in ComfyUI, which I will show you in a moment, you force the GPU to accumulate in FP16 instead of FP32. That means lighter and faster compute. Even if the model is stored in FP8, the GPU immediately converts it back to FP16 so it can perform the math. FP8 is only for storage. All the real compute still happens in FP16 or bfloat 16. And while the GPU is doing the compute, it still has to choose accumulate in FP16 or accumulate in FP32. That is why FP16 accumulation still matters, even when you are using FP6 or GGF models. Quantization changes how weights are stored, but the math always happens in FP16 or BF16, and the accumulation precision directly affects how fast the math runs. So then what is sage attention? Sage attention basically a faster, more efficient replacement for the standard attention kernel. It doesn't introduce new precision formats. It just changes the way attention is computed. It does this by compressing the parts of the attention mat internally using a custom highly optimized GPU kernel, still finishing the actual mat in FP16 because the GPU requires FP16 or BF16 for real compute. So in practice, it packs and quantizes parts of the attention mat. It replaces the slower PyTorch kernel. It keeps the final compute in FP16, and the result is much faster attention with a small or sometimes noticeably quality trade-off. That's really all it is. A smarter, faster way to run attention. So if I want to give a super simple summary, FP8 or GGF makes the model smaller. FP16 accumulation makes the mat lighter. Sage attention on the other end makes the attention step faster. Now let's look at how we can use this in an example with Flux 2. I am going to run this with a native PyTorch attention 2.8.0, which was what I was using in the whole workflow. We are going to do 2 runs because after every first run, because this is a new session of ComfyUI, second generation is going to be more accurate because the model is going to be stored. So let's run. And normally I should turn off my GPU recording of software for sure for performance, but for the sake of video, I want to show you guys what's happening. So I'm here. Okay. 1K image we are generating. I have a 5090. Let's run this. Model is loading. If you look at the terminal, and now generating. Sorry, my microphone was off. So we are generating with native PyTorch attention 2.8.0. We are going to do 2 generation per attention. I will try later pure sage attention without FP16 accumulation. Then I will also try sage attention plus FP16 accumulation. So this took 81 seconds. So I will copy this. I will say native PyTorch attention first run, and now my second run. You see how my VRAM is loaded, right? After the first generation. That's why I will also show you guys, sometimes you want to free up your VRAM. There is a basic note for that. After every generation, we can free up the RAM. It's useful when you are working with multiple models, different models inside one workflow. Okay, as you guys can see, we have a dramatic increase in performance. Second run is 53.0.5 seconds. Now I will try sage attention only. Let's go. Okay, now I am going to run my ComfyUI with sage attention with my installer script. I have 6 different ComfyUI installations. That's why the last 6 number represents. ComfyUI start sage 6. And immediately you will see here using sage attention. Okay, this is a different installation. Probably I'm going to get some errors because of the custom nodes that I don't have. No problem. Let's leave the page, reload this. Yes, of course, this is going to work. I don't get any problems right now. Now this is going to be my first run, first image generation with sage attention. And let's see, this is now using sage attention, first run. Look at the VRAM usage. It's loading the model. Okay, model is loaded. Now started generating. Okay, first run longer than this, but this can, I don't care about the first run too much. Lots of stuff can be affecting this, my GPU recording, etc. The second one is important for me, so let's run. Okay, as you can see, it is faster. Not much, but still. Second run, my terrible English. Now sage attention plus FP16 accumulation. I canceled my server, stopped the server, and the command that I need to use is sage with FP16. It is 166 66 because I have multiple installations. Yeah, maybe in a future update I will make sure that I use something like this so that it makes sense. Sorry for that. Now if I run this, what you are going to see, look at here, enabled FP16 accumulation and using sage attention. Let's refresh this. This is going to be my first run. Model is not in the VRAM, as you can see. Let's run. So I got 7 seconds faster between native PyTorch attention versus sage attention. And the quality, I don't know if you guys checked it, but it was almost identical. Now, this is very interesting. My first run is so much more faster. First run. Okay, very nice results. And let's run second time. It's so much more faster. I can see that. And think about it. I am recording 2K video capture right now. Okay, my second run is 42 seconds. So 4 seconds less than only using Sage Attention only. So the clear winner in this case is Sage Attention plus full precision 16 accumulation. So if you have 3000 series, 4000 series, and 5000 series GPU card, test Sage Attention with full precision 16 accumulation. You can really get some nice optimization. I will always do these benchmarks from now on in my whole workflows. For example, this is going to be more interesting when we are going to look at 2.2 video model, because we are going to start video generation in my next video. But for now, I am very happy with this result and the quality is awesome. I am going to create a post to image generator with Flux 1. So I will call this post to image. Let's enable this. Let's load an image and let's use my smart resize like this. And I'm going to use a node called, so the node we need is this guy, DV pose estimator. Put our image to image and stuff like that. I like to see an extra preview of what I am getting. And I will use an image like this. And now as you can see, this node has stuff like detect the hands, detect the body, detect the face, stuff like that. Everything should be fine. Yeah, now this is so much better. Sometimes, yeah, maybe that image was not bright enough. So now what I'm going to do, of course, we need my apply control net. It is this one. We need our flux model, base model. We need our clip. We need prompt with guidance from my custom nodes. Clip goes to clip. Let's make this organized. Zero condition for negative to apply control net negative. We need a key sampler. This will be our model. This will be our image. Let's get nodes and bring our variational autoencoder. Where is it? Here. And now we need to bring our load control net model. I will not put this into the global settings because this is something that I will only use here. And it is this Flux Checker Labs union. And this has to be connected to my control net. And my positive will get from my prompt, positive to positive, negative to negative. In this apply control nets, I don't want to go value 1 because then my image generation will be completely influenced by this. I want something like in between. 1, 2, 3, 4, 5 for seeds. We can do like increment. We don't want CFG and everything can stay same. Of course, we need a variational decode to decode our latent image. And variation autoencoder goes to my variation autoencoder file, and this will go to my preview. And I will say MN stretching. Don't forget your latent image, of course. This is a new image. I need my Flux latent image. And I want, okay, this size. Let's create this. Sometimes when you have lots of stuff happening, of course, you are going to get some errors. And I am using Flux 2 variation autoencoder. So this is a problem. Get node. We want Flux. Where is it? Yeah, it is here. So this was correct. I didn't have to do this, but in the end, the order is not important here. So let's run. Let's increase our prompt guidance, and it's perfect. Like it is all about finding the right values. So don't get discouraged. Oh, it's not working. No, probably you need to fine tune the values, and here it is perfectly following my pose. So now what I'm going to do, add a group, pose to image. I don't like the way this looks here, but I think it's fine. Now, there is a reason I keep doing bypasses for all the stuff. First of all, I told you this run command will run anything if everything is enabled, this run command is going to work, which is not important anymore because with the latest ComfyUI version, we don't use this. We have the partial execution. But the reason I am doing this bypass, because now our workflow is done. Now let's do some fancy tricks to make this workflow even much better. So what I'm going to do, first I will put this here, and I will also put, I need some more space. Okay. Now there is a node called, if you search for group, it is called fast groups bypasser. Okay, so as you can see, what is happening with this, it is listing all the groups that you created in your entire workflow. For example, the only one that's enabled right now is the global settings. If I click yes, it will disable it. Now, what I am going to do, I am going to modify this. First, okay, I want one like this, and I want this to be in here like this, or even I can do something like this maybe. Okay, this is better. I will make everything no. As you can see, I am enabling and disabling it like this, but I think this is looking much better like this. Yeah, let's keep it outside. It makes more sense. Let's make this a little bit better. Okay. Now this is all my groups. I will duplicate this and I will context basic. Where is it? It is there. So I will right click into this node. I will go to properties, match title. Okay, now it will remove everything and it will just keep this. And I will make it like this and enable disable. Okay, and for this one, I don't need this. I can just right click properties and show navigation to false. Double click. Enable text to image, duplicate, right click, properties, match title, image to image, enable image to image. It's enabling it. Now I will fast forward the video. I will make this for every group. Okay, as you guys can see, I added all the group enablers and matched to the group name. So it is only listing that, so I can enable them one by one also when I am like moving inside the workflow manually myself. And in the global settings, I can go, for example, I can enable this and go to that too. It is working, and I can then, if I want, I can disable it. But what would be nice, I still need to go to that global section myself every time. So what I'm going to do, there is a very nice node called bookmark. Again, it is from RG3. So if you, for example, keep the shortcut key to 1, okay, and this is the zoom level, you will see. Now I will go to somewhere else and I will click 1. It went there. So what I am going to do, maybe 1.1, let's go here. Okay, now we zoom more and I will put it to here and I will make this 0.5 maybe. Now let's go here, 1. So now let's try. Okay, the place of this matters. So you need to find like the correct spot for your this is almost, yeah, this is good. Now maybe 0.9, 0.8. Actually, I can just zoom. I don't need to see these global settings. It is better to see these. Yeah, I think this is so much better. And I can put this to here. So it is going to be like this. I will work on something. Okay, let's go to, okay, I did a pause. I disabled it. Click 1 on my shortcut. Okay, now let's do some detailer. Go to that one. If I forgot to enable from the global settings, I can enable from here, do my detailing, turn it off, click 1. It's perfect. Now, one last thing, we added lots of LoRa chain in our workflows, but we didn't use how to use a LoRa, which is super basic, but it has some tricks. So if you download and use my Arctic downloader, for example, I have some Flux Krea ones here. So I will just download this, for example, download this LoRa. You are not authorized to download. I said this in the first video. If you have this happening, you need to open your Civit AI API and you need to create a free API key. So Civit AI, and I showed this in my first video. So let me copy my API key, test, copy, paste, save token, download LoRa. Now, one thing very important when using LoRas, I added as much as the most important parts from Civit AI to this UI. One very important one is this trigger word. We need to use this in our prompt. And the other one is the suggested string. For example, for this one, what they say, it is better to use 0.9. Now, the trick is, for example, I will choose another one. This doesn't have a trigger word. Sometimes they forgot to add trigger word to the specific section that the Civit AI is asking the creator, and they just put their usage tips in the description itself. So if you don't see anything, read the description. As you can see, LoRa's strength between 0.8 blah blah is good. Now I don't list the entire description text here because in my opinion it will be overkill. If the description text is very long, I just put a read more link, and if you click this, it will open the Sweet AI website like this. Oops. And then you can find all the details. So as you can see, it is very long. I don't want to put everything into the app. Why it is good to go to the website? Because maybe they don't put that strength thing in the beginning, but they put it in the last of the text. So always double check their website. If you don't find the trigger word or the strength, it is probably in the description. Anyway, I downloaded this and it says trigger words. Sometimes the LoRa has multiple trigger words, so it is better to use and try all of them. But yeah, I will try this one because this is even the name of the LoRa. So I will go to Flux. I will go to text to image. What was the recommended settings? Strength 0.9. Okay. I need to, did I download this? Yeah, I need to refresh. I just need to click add LoRa and here it is, real comic. Here is the strength section. So this was the recommended value, 0.9. And now I need a prompt. I will go to ChatGPT. Give me a prompt for Flux Krea. I want to create a comic style girl who is running on a street with a bike, and use the LoRa trigger word real comic style. Okay, it gave me the prompt. As you can see, my trigger word is in the beginning. And remember, enable global settings. I need to use Flux Krea. Oh, I am already using Flux Krea. This is nice. Okay, yeah, my base model is set to Flux Krea. So I can just disable this. I can go to my text to image. Let's see if there is another. For example, the creator says 20 to 40 steps is fine, which is what I'm using. Okay, let's see what we will get. Not all the LoRas are perfect, by the way. Just keep that in mind. So there is something called training a very good LoRa. So it is like another skill which we will learn in this channel. So let's run this. Oh, so this is very important. This global settings needs to be always enabled. It is good that we received this error. So what I'm going to do, I will always keep this enabled because otherwise we are bypassing it. Okay, run. Here it is. It is super nice. It is using this LoRa. And actually, I really like this LoRa. Let's create one more. Wow, this LoRa is good. It is a very unique style. A young athletic girl running alongside a vintage bicycle. Oh, that's why. Okay, there is no... It is following the prompt. The prompt is not what I wanted. I wanted to ride a bicycle, not running alongside it, but this is fine. So according to the prompt, it is completely working. One last, yeah, real concern, a young athletic girl on a vintage bicycle, because otherwise running alongside is a different prompt. And yeah, you see, now I am getting what I want. In the other one, it is trying to put the girl next to the bike and trying to do something with the bike still, and it is making no sense. But yeah, this LoRa, I really like that. Anyway, if you want to add, you can add multiple LoRas. You can click, add another one. You can use 0.5 from one LoRa. You can use 0.2 from another LoRa. The strength, you can toggle all, disable all, and you can remove, right click and remove like this, and done. I will go to one, I will save, and this is what we created. And our all-in-one workflow is done. Let's see you in the next closing section. All right, we reached the end of today's video. We built a full all-in-one workflow for Flux Dev, Krea, and Kontext, and even set up a complete Flux 2 workflow with reference prompting. To wrap everything up, we benchmark native PyTorch attention, Sage attention, and Sage attention with FP16 accumulation. Sage attention gave us a clear improvement over native PyTorch, roughly 10 to 15% faster overall. And with FP16 accumulation, the gains were even stronger, about a 20% boost in speed. In the next video, we are going to dive into video generation with 2.2, and we will also learn how to create our own LoRas, for example, to maintain strong character consistency across images and videos. If you are enjoying these videos, please subscribe and hit the like button. It really helps with motivation. And feel free to drop a comment if there is a specific tutorial or workflow you want to see next. Thanks for watching, and I will see you in the next one.